So the next part is the exercise. So before I go to the exercise, I'll mention again that today's lecture is already uploaded by Professor Gyan. So on the function as a service and the serverless computing. So the video is already there, so you can see it. So before going into the exercise, so let's start with the solution of the last exercise. So the last exercise was where you have to deploy or build a microservice application, which comprises of the 4 microservice, the server microservice, hello world, product description, and the product price, and then invoke it using this URL and get the response. So this was incomplete, which you need to complete. So as part of that incomplete part, so you can see over here. So the first thing is the pattern, which is like over here the product, and the command is the product URL, which is finding the URL of the product ID passed into the microservice. So for that, either you can run it iteratively over here, or there are different functions within the Node.js, like filter function for checking out if the product ID matches with the product ID sent by the user. And once you found it, you can break it and then send it back as a response. So the one thing which I noted that some students were missing this result. So this result is required because in the server microservice we are doing is a URL.result actually. So that's why I had to get the result over here. Similarly for the product description, so similarly you have to do it here for check the product ID, get the product description, product name, and send it back to the user. Similarly for the product price. And within the server microservice, the product price was missing, where you have to specify the pattern and the function which you have to call over here. So does anyone have any questions in the last exercise? Or how would you rate that exercise? Was it difficult? How many says it was very difficult? Easy? How many says very easy? Few of them said very easy, yeah. Medium? Anyone for medium? Yeah, few of them. So the next exercise is about the Kubernetes. So how many of you have once or anyone like at any time deployed a Kubernetes cluster by like from scratch? So which tools have you used for deploying it? Do you remember?
Which tools?
Yeah.
I deployed it on DigitalOcean.
So you use their service, like the service from them?
I like the service.
Yeah, okay. And you? You also use the service provided by the AWS. So anyone who deployed it from the scratch itself, like if I give you a virtual machine, then deploy the Kubernetes cluster on top of it. Yep. Yeah.
Yeah, I don't remember how I did that.
Okay. So we will learn as part of this application. So we are deploying the Kubernetes cluster from the scratch itself. So there are other ways, like they mentioned they used EKS, which is the Elastic Kubernetes Service from AWS. So where AWS is providing you the Kubernetes cluster, so they are managing it for you. Or you can even use the Google ones. The Google also has similar ones. But here we want to deploy it from the scratch and then deploy our application on top of it. So before deploying the Kubernetes cluster, so let's see how the application architecture would look like if you deployed on the Kubernetes cluster. So we are using the same application as the last one, the exercise 3 application, where you have the 4 microservices, and these 2 microservices are attached with the mock data. And once you send a request through this URL, you get a response like this. So now we need to convert it into a Kubernetes-based deployment for this particular application. And for that, so you would put not inside the container, each microservice you would put inside the pod. So each microservice go inside the Kubernetes pod, as you can see over here. And within the pod, there would be the container for that microservice, which is running. And over here, you can see the deployment and the replica set. If you remember in the Kubernetes lecture, we discussed about the deployment and the replica set, which is a high level layer for managing the pods. And here we can see there are two replicas for the server microservice. And now the next question is how the communication would be done from the server to the individual microservices, and this is done through the kube service. So within the Kubernetes cluster, you can specify them as a cluster IP service. So does anyone remember what different kinds of kube services are there? So one is the cluster IP, which I already mentioned it over here. There is a second, third, anyone? Node port is the second one, and the third one is the load balancer service. So load balancer service, what it does is if you have an external load balancer, then you can send as a load balancer, then it will load balance among the individual replica sets and do the load balancing of the invocations. So now over here you can see the client sends to the load balancer service of the Kubernetes, and then it will do a load balancing between the individual pods of the Kubernetes of the server service, and then it will send it the request to the individual microservice which are running within the pods. And this communication is done through the cluster IP service of the Kubernetes, because we don't want them to be exposed to the outside network, so it only stays within the Kubernetes cluster. So this is all deployed on a single virtual machine. So you can deploy it on the multiple as well, but as part of this exercise, we will deploy the Kubernetes on a single virtual machine and then the application on top of it. So over here you can see your last API would still work because it's the same exercise, and the additional API which you have to add is this API/exercise 4, which we'll see what it will send the data. Does anyone have any questions regarding this architecture before I go into how you can deploy a Kubernetes cluster? So you can also use a node port over here also, because we don't have an external load balancer, so it will anyways by default expose it as a node port only. So now the next part is how you can install a Kubernetes and run the application. So for that, it's the same procedure. So you have to create a virtual machine, and you have to be careful that it should have at least 2 virtual CPUs. If you try to deploy the Kubernetes on a virtual machine with less than 2 virtual CPUs, it will not work. And another important point is the ports, which you have to open within the firewall rule. But this is only required if you are building a Kubernetes cluster with multiple virtual machines. So as part of this exercise, we are only deploying on one virtual machine, so you don't have to open up all of these ports. So the next is you SSH into the virtual machine, which will act as our master virtual machine of the Kubernetes cluster. And once you SSH into that, so you have to install various packages. So one installation is the Docker, which is in the similar as the last exercise. So I will not go into the individual commands. So these are the same as the Docker installation commands. Then once you have installed the Docker, then you have to install the Kubernetes. And within the Kubernetes, you have to install the kubelet, which is deployed on each virtual machine or each worker nodes. Then kubeadm. Has anyone used kubeadm? So this is the tool which we are using for deploying the Kubernetes cluster. So there are other tools as well, like the kubespray, or K3s, but we will be using the kubeadm tool for deploying the Kubernetes cluster. Another is the Kubernetes CNI for managing the network interaction between the pods. So once you have installed all of them, so if you run the kubectl command, you would see this thing over here. So this is like the kube control, the CLI for the Kubernetes for managing the deploying of the pods, deleting of the pods, exposing and getting the details, getting the logs, and all of that would be using this kubectl command. So once you have all the packages installed, so next command you have to run is the kubeadm init. So this is like the initialization for my master. So like I want my master node to be working. And the next thing which you have to specify is the network CIDR, which is like the IP addresses which the pod would be used within the Kubernetes cluster. So this is required for the CNI plugin which we are using. So it needs to know which range I need to use for interaction between the pods or the services within the Kubernetes cluster. So once you run this, so this is like, if you see, this is an old version, so it's now around 1.24 or something actually. And once you run this, in the end you would see something like this actually, kubeadm join command. So this is the join command if you want to run the same, if you want to attach another node to the same Kubernetes cluster, so you need to run this join command on that particular node. So then it will join, you would have a multi-node Kubernetes cluster. But here we are not doing it, so you can skip this command. But you have to run this command, these three commands which are listed over here as well. So this is just copying the Kubernetes configuration file from the one directory to your user directory. So let's say I am a root user. So this has to be run through the root user command, and you want that Kubernetes to have access to another user as well. So then you run these three commands. So then you copy the Kubernetes configuration file into that user directory. So once you have done that, so if you do this kubectl get ready, get nodes, so you would see the nodes which are part of your Kubernetes cluster. So currently you can see it's one node and its status is showing as not ready. So you would also get a similar status if you run this command. Now to make the status ready, so you have to install a pod network. So you remember we were running the pod, the CIDR, which is required for the Kubernetes network interactions. And for that we are using over here Flannel. So you can use any other, so these are listed on this page. So there is a Calico also, which is quite famous. Flannel is quite famous. So you can use one of these plugins for building the interactions between the pods and the services within the Kubernetes cluster. So once you run this, so you would now see kubectl get pods. You will see multiple pods starting up. So these are managing all the Kubernetes cluster for you. And if you do get kubectl get nodes, now what you see, you would see the status of the node as ready. So now your Kubernetes cluster is up and running with one master node. The only problem which now remains is by default, the Kubernetes does not allow you to schedule a pod on the master node. So like an application pod. So you can schedule the management nodes on the master node, but not the application pods. And for that you have to taint it. Taint is like, let's say like removing a color from the node, and so that the pods can be scheduled on the master node. And once you do it, then it will say that it's untainted now. So now you can run your application pods as well as on the master node. So if you remember in the lecture, we discussed about the various workloads within the Kubernetes. So one is called as a replica set, which is for managing the amount of replicas for a pod. The other was the deployment, so which is very high level for, again, managing the pods. But the only difference between the deployment and the replica set is how you do this, like a revision history, or it's called as a rolling update. So if you want to do a rolling updates of your application, that is only within the deployment, not available as part of the replica set. So this is already described in the lecture part, so I will not go into the details. So now, so we have our Kubernetes cluster ready, up and running, and now we can schedule the pods on the master node. So the next thing is how we can run our application on top of them. So for that, we have to write a YAML file, which is, let's say, like for a hello world YAML file, which is the same YAML file as the deployment. So you specify the kind as the deployment over here, then the labels, then specify how many replicas you have for the particular pod. And then you specify the template of the pod. So like the template specifies like what is my container image and what is the container port. So you can specify the name as well over here. So this is like all you require as part of the deployment. So if you from the high level, if you see the deployment, then the spec of the replica set, then the spec of the, or the template of the pod, then the spec of the container itself. Similarly, you would have this for the other product price, server, product description, which are missing in the application code which I'm giving you. So you have to write that. And once you have written this, then you can run this command, kubectl apply -f, then specify the name of the YAML file. Like over here, you can see hello world, product description, product price, and the server. So this will make my deployments up and running. So now if you do kubectl get pods, you would see all my application pods running within the Kubernetes cluster. Over here, hello world, product price, product description, and the server. And similarly, if you do kubectl get deployments, you would see all my deployments running over here. The other thing which I'm doing is all namespaces. So you can see there are multiple namespaces within the Kubernetes. So even if you skip this, it will show for the default namespace, and that's where your application is running. So the next is, so now we have our application running, or the containers are running. So the next thing, if you remember in the architecture diagram, we have to build the services for the interaction. So these are the services. So for the hello world service I'm showing you, so for the hello world it's very simple. So you have to specify the kind as a service, then the selector points toward that particular deployment label, which is a hello world, and then the port where this particular container is running, and the target port of the virtual machine. So once you run this, so you can see that I'm not specifying the type within this service. So by default, the type is the cluster IP. So if you are using a load balancer or a node port, you have to specify the type over here as well. So similarly, so you have to write it for the product description and the product price service, which are missing. And once you run this, you would have this commands as an output, the service created, and service created. So now, so you can see all the three distinctions, like there is a pods, there is a deployment, and then the services. So now you can see kubectl get services, all my services running with the different cluster IPs, and then there is a load balancer for the server service. The one thing over here, you can see this is pending because we don't have an external load balancer attached to it. So it will stay as pending unless we attach like a AWS load balancer to this server service. So it is fine. So because for this application, for this exercise, we are not attaching. So we are using the node port exposed by this service, which is called as the 31877 over here, which is a node port. So if you now query your virtual machine, then the port number, then the same API request as the last exercise, you would get the response of the exercise. Yeah, so here this one is the node port which is exposed over here. So for accessing this thing, you have to enable this port number within the firewall rules of your virtual machine. So don't forget that. And this number would change for each deployment. So the next question is now left is, if you remember in the architecture diagram, there were two replicas for the server service. So now we need to scale the server service. So this is done using the scaling command, which is called as the kubectl scale, then the deployment. Over here, my deployment name is the server deployment, and then the number of replicas I want for that server deployment. So like before it was like this, 1:1, and now it's like 2. So 2 replicas for the server deployments are running. So this is so if you want to delete the Kubernetes cluster, but do that only once you have done the exercise and it's successful. So you can delete using the delete command for individual deletion of the service, deployment, or the pod, using like this. Or if you want to reset the whole Kubernetes cluster, you can run the kubeadm reset command. And once you run the kubeadm reset command, you have to also remove the configuration file which was copied into your user. So this is how you can set up the Kubernetes cluster, deploy the application on it, and run it. So now as part of this exercise, you have to add an additional API request, which is the API/exercise4, where you would send a message Like if you did it for the second exercise, group, then the group number, application deployed using Kubernetes. The rest remains the same. The main purpose of this exercise is for you to deploy the Kubernetes cluster and then the exercise on top of it. Start the Kubernetes cluster, install the pod network, enable pod scheduling on the master node using the taint command, run all the microservices deployments, create the Kubernetes services for all the microservices, scale the microservices to 2 replicas, and this you don't need to do. This is only required if you want to locally map the port of the Kubernetes. And once you do it, so then the next, which is missing over here, expose the node port the node port which is exposed by the server service. Just enable that into the firewall rules before accessing this over here. And that's it. In the submission, it's same as last exercise, but now you have to add that particular port number as well, which is exposed by your Kubernetes. So, and the IP address on which the virtual machine, your application is running. And the deadline is 2 weeks from now. Yeah. Thank you for your attention. If you have any questions, you can ask. Yeah.
Do we have to manually type this command for scaling? Can't we just specify the number of replicas in the deployment YAML?
Yeah, so the question is, do you have to specify it manually? No, you can change it directly in the YAML file also. It is just to show that there exists this command, which you can use it for scaling if you initially didn't do it. Any other question? So for the last exercise, we currently have 2 options. So either we can give it on the next week, and then you would have 2 weeks for this exercise, and then the 2 weeks for that exercise until the end of the whole lecture period, or we give it at the 2 weeks from now. So then you have to work like an extra week for that exercise after the exam is done. So I'll put a poll on the Piazza. So depending on that, we will make a final decision whether to do it on the next week or do it on the next to next week. Any other questions or? Yeah. So the question is whether the commands which we discuss as part of the exercise will be asked as part of the exam. So no, we don't ask the commands in the exam. So you don't have to remember the exact syntax of the commands for the exam. We will not be asking.